The notes for lesson 2 in unit 3 is how can we tell a chemical reaction is happening. So before we take the notes for this section, you will want your notes packet. So if you're using my printout or the template, it looks like this. We would be all the way on the top of page 4. Nope, just kidding. In the middle of page 3. So section 11.1, chapter 11, describing chemical reactions. So make sure you have those notes available. Also make sure you have your periodic table packet available. And here we go. Section 11.1 is on describing word equations. So this is getting into writing formulas from words. So reactants are the term for elements or chemicals that start a reaction. So they appear on the left side of the arrow. And then products are what is produced in the reaction or what comes out of a reaction. So products are the chemicals or elements that show up on the right-hand side of the arrow. So if you were going to write the word equation for the statement, hydrogen peroxide decomposes to form water and oxygen gas. First, you have to figure out what your reactant is, and then you have to figure out what your product is. So using the words, we know that hydrogen peroxide is decomposing. So hydrogen peroxide in this case is going to be our reactant. To form means that it's producing, so that's going to be our arrow. So it's producing water and oxygen gas. So this would be our word equation. And then you can also take those word equations and turn them into chemical equations. So when you do this, you have the formulas of the reactants on the left-hand side of the arrow and the formulas of the products on the right-hand side of the arrow. So the skeleton equation is the basic equation that you would take from word format to formulas. So the skeleton equation is a chemical equation that does not show the relative amounts of chemicals. So an example would be Fe plus O2. Remember, oxygen is diatomic. So oxygen, when it's by itself, has to have the 2 after it. And then produces is your arrow. This would be iron 3 oxide, but it'd be Fe2O3. So this shows that we have iron and oxygen reacting to form Fe2O3, but it does not show how much iron we need or how much oxygen we need. It is just the basic skeleton equation. So what we have to do in this lesson, another term that you'll see in chemical reactions is a catalyst. You may have heard of a catalyst in biology when you're talking about enzymes. Catalysts are substances that are added to a chemical reaction to speed up the rate. So a catalyst will make the reaction go faster. When you have an example of a reaction, the catalyst, which in this case is Ki, it's in red and it's written right above the arrow. The catalyst is not included in the reactants or the products because those molecules are not split up and rearranged in the reaction. It's just used to speed up the reaction. So we have H2O2, which is actually hydrogen peroxide. It is breaking down into H2O and O2. So if you've ever had hydrogen peroxide at home, it's in a brown bottle. You probably keep it in the bathroom. You use it on cuts and it bubbles. If it's a really, really old bottle of hydrogen peroxide and you pour it on a cut, if it does not bubble, that means it has already decomposed into water. So the reason it's in a brown bottle is because light will also work as a catalyst to speed up the reaction. So if it's in a brown bottle, then that's blocking the light, so it'll slow down the process. So in this case, Ki is a catalyst used to speed up the reaction, but it's not actually used up in the reaction. Another new piece you'll see is the AQ and the L and the G. Those represent states of matter. So it tells you whether it's a solid, a liquid, a gas, or an aqueous solution. So one major difference to note is the difference between a liquid and an aqueous solution. A liquid would be like a pure substance. So water, for example, is a pure substance. It is a compound, and at room temperatures, it is a liquid form. Aqueous means that the substance is dissolved into water or is dissolved into a solvent. So basically, like Kool-Aid would be an aqueous solution, coffee would be an aqueous solution. Most of the chemicals that we use in the lab are going to be aqueous. Really, the only pure substance that is a liquid that you will see will be water. The other substances with that consistency are going to be aqueous solutions. All right, so that is it for your section 11.1 notes. We'll work on changing word equations into skeleton equations, and then tomorrow's lesson will deal with balancing equations.